This is a calculator-related problem, and so I'm going to go second plus 712 and clear my calculator. Second plus 712. I'm going to advise you to do that after question 1. Again, question 1 and 2 for FRQs are question-related. You'll have a total of 30 minutes to complete 1 and 2. It's not broken down into 15 minutes for question 1 and 15 additional minutes for question 2. You can go back and forth between the two. Most students will work and try to complete question 1 in under 10 minutes, allowing them extra time for question 2. Let's get started. Okay, a student won $3,000 in an art contest. At first, the student decided to keep the money at home. After 12 months, the student deposited the money into a high-yield savings deposit. 6 months after depositing the money in a high-yield savings account, the money, this is when t equals 6, in the account is worth $3,066.76. 12 months after depositing the money, so t equals 12, the amount is $3,135 exactly. So M of t is the amount of money in dollars at time t in months. We know the initial investment is $3,000. The negative value for t represents the number of months before the student decided to deposit the $3,000 into a high-yielded account. Let's get started. Part A says use the given information to write two equations that can be used to find the values and constants for A and B. It does not ask us to solve. We simply are going to state the two. Now, we already can see here's the basic equation. So I'm going to start with M of t. Now, how did I know that? Because M of t, right? So M of t equals, and then I have A times B raised to the t over 12. Now, I'm given two ordered pairs. I'm told at 6 months, there's $3,066.76, and I'm also told at 12 months, there's $3,135. And so my two equations look like this. This is my output. So 3,066.76 equals A times B. My input value is 6 over 12. My second one is $3,135 equals A times B, and again my input value is 12. Do nothing more. Don't circle it. Here are my two equations, and that's how they were formed. That's worth 1 point. Normally I would say the second part says find the values for A and B, and normally I would say, hey, don't take time doing algebraically. We're going to plug it into a regression model, and by plugging in we can come up with our answers. The problem is depending on how you have this set, it could be slightly off. So let me help you with this. Algebraically we can do this as well. I have two equations. Let me write them down. I have 3,066.76 equals A to the 1/2, because 6 divided by 12 is 1/2. And then I have 3135 equals A times B to the first. Now, I already know what A is. A is the amount that we have in the account that is initially placed into the account. And we already know that we have a total of 3,000 initially placed in. A always represents that initial amount. So I can right away replace this. I know A is the initial amount, that is $3,000. Done. Okay? And so I can come to either one of these. I just think it's easier to work with B to the first. But I could go to either one, and I'm going to replace A with 3,000, and this is B to the first, excuse me, B to the first, and then I'm going to divide by 3,000. I'm going to grab a calculator and type in 3135 divided by 3,000, and there's my answer. So B is equal to 1.045. This is my A and this is my B. Again, how did I know this is my A? A is always the initial amount that is input. In this case, it is 3,000. If you chose to work with this first equation, we can still come up with this, and I want to demonstrate that right now. If I plug 3,000 in here, and I'd B to the 1/2, the reason you can see why I'm not choosing to do this is I had to do a few more steps. First, I would divide, and I'd come up with some number on my calculator, but then I'd have to raise it to the reciprocal of this exponent, which is 2 over 1, and then I would square it. We'd come up with the exact same amount. This is my A, this is my B. Again, I chose to work with the second equation because I didn't want to work with an exponent that was a fraction. So I've completed my A, and I've completed my B. Let's move on now to part B. Okay, so we're moving on to Part B. You're going to see consistently the same type of question. We want to find the average rate of change, and we want to show our work. So I'm going to do y2 minus y1 over x2 minus x1. You're thinking, where am I getting these values? Well, it tells me use -3 and use 12 as the input values. Remember, they represent months. Now, at -3, that represents 3 months before we deposited the $3,000. Remember, from 12 months before all the way leading up to the point where you're depositing it, the money is just sitting in the account. And we can see that right here. We can see that the student wins $3,000 in the art contest, and for 12 months it just sits there, and then finally she deposits it into a high yield account. Now at 12 months, let's figure out how much money remains in this account. Okay, at 12 months. So I have an equation. Remember, I have an equation that I can use, but I'm going to go right here, and it says at 12 months there's $3,035. $3,135. Okay, so I have y2 minus y1 over x2 minus x1. It's important to use those parentheses. And 12 subtract a -3, and you can see we come up with a value of 9. Okay, so again, express your answer as a decimal approximation, show your work. I've done that. Now, what does this represent? That is going to be the key. This represents an increase of $9 per month. Now, how did I know it's months? Because that's what time is in terms of. $9 per month from t equals -3 to t equals 12. You do want to do an explanation, a brief explanation, doesn't have to be a complete sentence, of what this number means. Let's move on to the next. The next part says, hey, use this information and specifically use the other point of when m equals 12 to come up with the average rate of change to estimate, okay, when t equals 20. So we want to come up with an actual equation now. We want to come up with an equation. So y equals mx plus b. And so we've already created what our slope will be, or the rate of change between t equals -3 and t equals 12. And then when you're thinking, well, what other point should I use? It specifically says, hey, use the point when m is 12. Okay, so what did 12 go with again? If I look up above, 12 months after being invested, you are at $3,135. What am I going to do with those extra points? This is going to be my x, and this is going to be my y. And I'm just going to go ahead here, and I will take 9 times 12, okay, and then I'm going to subtract 108 from both sides. It says it wants to see this computation. I'm doing exactly that, okay, and I get 3,024 equals b. So this is my equation. So it is 9x plus 3,020. That's my equation. That's my linear equation. And with that, it wants us to calculate what would be the amount in this high-yielding savings account when t equals 20. And so, and by the way, we can write it like this because it does say, hey, you can write the average using this average rate of change like this. So this would also be fine. Now we're going to figure out a of 20. That means wherever I see that input value, I'm going to input in 20. 9 times 20 plus 3,027, and we can see we have $3,207 and no change. Let's go on to the next. So many of you were very close to receiving credit on this portion, and I get that this particular part of the problem seems a little intimidating, and so if you have time, it's a great problem to earn an extra point on. But if this happens to be the one part maybe you don't earn that extra 1 point on, do not feel bad. This is tough. So what we're going to do here is we're going to define what is A of t. That's the one that uses the average rate of change, and then we're going to define what is m of t and talk about what these graphs look like. So A of t is the estimate in dollars using the average rate of change. Okay, we created that equation already, and A of t is used to estimate the values of m and t. So it was created when t is greater than 0. Great. There's an error in the estimates, and it will increase as t increases. Explain why this is true. Okay, so I'm going to first just define A at t is a secant line created from rate of change from t equals -3 to t equals 12 using m of 12. What does that mean? It just means what I did in part 2. Remember that I found the slope, or the average rate of change, and then I used the point 12 comma 3,120, what was it, 3,135 to create that equation. Let's find that really quickly. That's this right here. I just created that. That's all it is. I just defined. How did I come up with this? I found the slope, and then I used that extra point because it specifically said use m of t. So the input value is t, and here's the output value. Okay, let me go back to my paper here. There we go. So I've defined what a of t is, and then I'm going to say m of t is for the t values greater than or equal to 0. Again, how do you know this? We know this because we're told that for m of t, this equation, which is that exponential, is for only when t's are greater than 0, right? This is when you actually invest the money. Sorry. Here we go. M of t is when t is greater than 0, is an exponential growth function that increases as t increases and is concave up. So when we think about this picture, right, when we think about this picture, we could draw that. Give me a second here. Look at this basic picture here, right? This is my A of t, and this is my M of t. And so they're saying, why is there an error between your estimate and between the actual model when t is greater than 0? And we can see that as t increases, the difference between the estimate and the actual model just continues to increase, right? The output keeps going up and up and up for M of t, and the A of t, although it keeps going up, is just getting further and further apart from one another. So A of t, the secant line, is below M of t, and they're saying specifically at what? Specifically for t greater than 12. Thus, A of t is a smaller estimate of M of t. As t increases, the distance between A of t and M of t increases. Thus, the error increases. Ooh, does that ever seem wordy? Again, if you have time and you could put 2 minutes into this, awesome. But if you can grab points from all the other sections, you're doing well. I actually, for this type of problem, would probably skip over doing this part and only do it at the very end. You'll see a timer at the very top of your computer as you're taking this test. You'll be writing in a book for the FRQs, but on your screen you'll see the actual questions. I would skip over to part C and then come back and leave whatever time I have for part B to expand. So student plans to close the count when it reaches 5,000. So basically I want to know, when is M of t equal to 5,000? So I'm going to write down the equation I have. I'm going to look back here. Remember that I have my A and I have my B. So I'm going to write down what it was. It was M of t equals A times B raised to the t over 12. And I want to know when does M of t equals 5,000? So I'm going to take my calculator and I'm going to clear it off. This is quick for us, and then we're going to relate it to the domain, which will go really quickly. Okay, ready? We have 3,000 times 1.045 raised to the, and in parentheses, we don't use a t, it's going to be x divided by 12. Now, I want to know, when does that meet 5,000? I may have to do some zoom fit here. Let's see here. Now, we're talking about months, and so I'm going to go, and we're going to assume maybe this takes many years. Every year is 12 months. Let's go out to like maybe 5 years, so 5 times 12 is 60. Let's just see what this looks like. I'm doing a zoom fit so I can see. Okay, so it's going to definitely take more than 5 years, so let's expand this out more. Let's take that and let's go out, I don't know, let's double this and let's see here. After 10 years, are we getting closer? Closer, but not there yet. So I'm just going to do an arbitrary number, like 200. Yeah, we're able to see it then. Okay, so here we go. Second, calculate. Let's find that intersection. Okay, I can see it. So we have when t is approximately 139.263. Okay, so we are supposed to now identify the domain limitation. So let's go back to this original problem. For m of t, we start at negative 12. So I can say the domain, okay, it includes negative 12. It's important that we include it. We include negative 12, so we have a bracket. And M of t will be, this account will be shut down when it equals 5,000. Well, how many months is that? It's 137. This was negative, excuse me. This was negative. This was negative. And it's going to go to 139.263. And we're going to include that. That's when it is shut down. And you may just want to write graph and found intersection, just so the reader knows how you did that. I think this is much easier to gain a point on, and then if you have time, you come back to this part.